All right, and welcome back, everyone. Today we're going to be looking at our Chapter 5 test review. Um, this will be a little bit long because I'm going to go through each and every question on the review, kind of showing you what I would expect or how to approach these questions on your test. Um, One thing I'm also going to be doing is going through all the sections on this test and making sure the keys to the notes are posted. I know quite a few I kind of missed throughout this chapter, so I will be making sure all the notes are posted. This review video will be posted. There'll be a key to the review, so hopefully you have a lot of resources to kind of look at when you're taking your actual test. But without further ado, let's just kind of jump in, start going through some of these. I will be going in order, so if you're looking for a specific question, try and skip around. Hopefully you can find it. I don't know how to do timestamps or anything like that, unfortunately. But the first two questions on your test, they're going to say write each polynomial function in standard form, classify it by degree, and then determine the end behavior of its graph. So there's three things they're asking us to do. The first is to get it into standard form. So for question one, you might look at that and be like, well, isn't that in standard form? It looks like it, but remember, in standard form, it has to have the highest power, then the next highest power, then the next highest power, all the way down until the constant. So we kind of just need to switch the order around. Like we got to put our x to the fourth part first, then our cubic part, then our quadratic part, then our linear part, and then lastly, our constants. Just separate that from question two. So this would be in standard form. The next thing they want us to do is classify it by its degree. Remember your degree, you look at your highest power in your function or equation. So this is a fourth power, and the proper, or kind of like the way we would classify that, that is called a quartic function. And I wrote down the names of degrees up here. Keep in mind, if it gets bigger than a fifth degree, like if you had a sixth power, we usually just say it's a sixth degree function or it's a seventh degree function. I'm sure there's some mathematicians that deal with those a lot. I'm sure there's maybe a more of a proper name for them, but for your, uh, I mean, your average mathematician, like you're really not going to come across a lot of sixth degree or seventh degree functions in what you're doing. Um, so check. And then the last thing they want us to do is determine the end behavior. So you want to look at your degree and your leading coefficient to see if it's positive or negative. So this is a negative even function. So you can use this table here. So a negative even function though would open down and down, or that would be the end behavior. Um, One kind of side note, obviously you can use your notes on this online test, but if we were in person, like I would not give you um, what's written above here. You would either kind of have to learn this or know these, but one tip for the end behavior is just think of basic kind of cases, like a positive x squared or quadratic opens like that. It's a parabola, right? A negative x squared function would open down and down. So you can see like a positive evens up and up, a negative evens down and down. And then for your odd functions, if you think of like a positive cubic function, it's kind of like that bent paper clip shape, but it would be down and up. A negative cubic function would go up and down. So if you can kind of think of these base cases, you could apply it basically to every situation. So you don't have to memorize this table necessarily. That would be my advice. Anytime you can avoid having to memorize stuff, usually you'll be better off when you get into more advanced concepts. Um, all right, but let's look at question two. So first we want to get it into standard form. So we're going to have to FOIL this one out. So if we FOIL it, we'll have 2x cubed minus 2x minus 5x squared and plus 5. So we want to rearrange that so it's in our standard forms. We got to swap the x squared and the x part basically. So that would be our standard form here. All right, classify it by degree. That's why we want to get in the standard form. We wouldn't have been able to easily, sometimes it's a little bit harder to see when it's not in this form, but that's a third power, so it's a cubic. And in this case, we have a pot. Oh, no. Okay, let me undo that, sorry. Our leading coefficient's positive, so it's a positive cubic or positive odd function. So that would go down and up. So we answered all three parts. So the directions on your test for the first two questions will be pretty much, I mean, it will ask for these three things. So like these are what you'll see in the first couple of problems on your test. Okay, let's move on to question three, similar kind of topic. So they're going to give us, they're going to give us a graph and we're going to be asked to find the coefficient and our degree. And let me just clarify, when I say coefficient, basically you're going to tell me if it's positive or negative. And then for the degree, you should actually be able to get your degree. So remember, well, looking at this graph, if you see that it opens up and down, that's a negative function. Well, maybe I'm kind of going out of order here. Let's find the degree first. So apologies if this is confusing at all, but you should see it has 3 zeros. And if you remember, if it crosses through like that, that's a multiplicity of 1. So you really have 3 multiplicities of 1 or a degree of 3. So our degree is 3, or you could also say that it's cubic if you'd like. And then for the coefficient, since it opens up and down, I mean, you could look at this table, but you should see that that's this situation here. So that would be a negative cubic function. So your answer would be it's a negative third degree or a negative cubic function for a question like this. So basically figure out what your degree would be and then use your end behavior to see what situation. So for example, let's say you had a degree of 4 and it went up and up. Well, that would be a positive fourth degree function. So, but let me know if you have any questions about these first three. But these three questions all kind of come from our first section, 5.1. But you'll see very similar questions. Like I'll give you 2 questions like that, and I'll give you a graph where you're supposed to answer these 2 questions as well. So the format of the test will be very similar to this review. All right, moving on. All right, question 4, we've got a lot going on in this question. And I had to kind of remake this question because the one in the review didn't really work out how I intended it to. But the first thing you want to do is just find some basic information. Remember, your degree is your highest power. So this is a 3, or you could also say that if you want to say the name, it's a cubic or third degree. I really don't have a preference. Your leading coefficient, so your number in the very front. Just make sure it's in standard form. I'm pretty sure the problem on your test is in standard form as well. But keep in mind, like for these questions, like make sure your function or your equation is in standard form before you start messing with it too much. Your end behavior, since it's a positive cubic function, if you either reference that table or just think of a basic cubic, that would be down and up. So these first 3 questions you should be able to just kind of answer by just kind of looking at your function. You could also even wait, like for the end behavior, you could graph it and kind of see what it looks like if that's necessary. The next thing we need to do is find our x-intercepts or our 0. So you're going to want to try and factor this down, and I will give you a problem on your test where it should be able to factor without having to say use synthetic division like we saw at the end of chapter 5. So in this example, we can factor out an x. And then this trinomial we can also factor down. So what multiplies the 3 and adds up the 4? Well, that would be 3 and 1. And then remember when you solve, like you would set each one of these pieces or terms equal to 0. So I mean, we're going to have a 0 from the x. That plus 3, if you solve that, that would be negative 3. And then your x plus 1, if you solve that, that would be a negative 1. So I'm going to start, like I said, and if you're not able to print this off, you could just kind of draw a really rough coordinate grid, but I would plot your 0. So we have a 0 at 0, We have one at -3. I'm going to zoom in just so I can try and be a little bit accurate. And then we have one at -1. Okay. And if you want, you could also draw on your end behavior because from this 0, it's going to go down. And then on the right, it's going to swing up. So we've kind of got this all figured out. Our y-intercept, I mean, you can actually already see it on our graph. It's at 0, 0. But basically, to find your y-intercept, you're going to want to plug 0. Like your y-intercept is always going to be 0, comma something. So you're going to want to plug 0 into your original function. But if you plug 0 into this function, like that would just be 0 plus 0 plus 0 or just 0. So that's how you get your y-intercept. You could also look at your graph potentially in your graphing calculator. Probably maybe be able to see that depending on where, if it's like on your graph. It might be off the window though. That's the only flaw. Okay, our local max and min, I'm going to put stars by these. We have to use a graphing calculator for these because a lot of times these aren't going to be super nice. I'm just going to, here, I'm going to pull, okay, I got it. Here, I might have to flip back and forth, but x cubed plus 4x squared plus 3x, x cubed plus 4x squared plus 3x, x cubed. Oops, clear that. Oops. X cubed plus 4x squared plus 3x. So we're going to graph our function. As you can kind of see, it kind of looks like what we've already started to kind of get sketched. Like I said, we're going to find our minimum and we're going to find our maximum. Remember, these are called local maxes and mins because they're not like, this actually isn't the highest point of my graph. And this isn't actually the lowest point of my graph, but it's in this relative area. It's the high point and the low point from like kind of the main part of your graph before it shoots all, keeps going up forever and goes down forever. So to do this, remember, you press second trace. In this example, I have a maximum and a minimum. I'm going to find the maximum first. So you should see your X. You might have to kind of move your cursor using these left or right buttons until it's on your screen, but you want to make sure that this X is to the left of your maximum when it says left bound, and when it says right bound, you want to make sure your X is to the right of it. And on this application, it calculates it right away. If you look on the bottom of my screen, it's that P1 point, not the bottom point. Like it's here, let me annotate it really quick. But this is the maximum here. Not this. This is just where my cursor was. So be careful about that. So it's about -2.2, 2.1. So -2.2, 2.1. And I'm going to go ahead and I'm just going to sketch that. So -2.2, 2.1. Maybe it looks kind of like that. So our graph's going to kind of do something like this. It's going to have to come back down to that other point. And then we're going to go back to our calculator. We're going to find our minimum. So we're going to do second trace, minimum. Make sure your X is to the left of your minimum value. And then make sure your X is to the right of your minimum value. And then it popped up. Like I said, it's just make sure you're looking at this part here. It's kind of cut off. It does say, it usually says like max or min here. I don't know why it's not showing up, but don't look at this. This just tells you where your cursor is. Like, so that's like where I moved my cursor when I did my last X. So in this app, it's the top, but kind of use where it looks like it's on your graph too. A lot of times you should be able to kind of distinguish. So I'm going to round that to -0.5, -0.6. If you rounded it different, like I said, I mean, I will not, I'll be, as long as it's close. I mean, it's not like completely off the mark. I'm going to pretty much take everyone's answer. So, so -0.5, -0.6. I don't know, it would be maybe around there. So my graph would look like this. And I mean, you can see from the graph and calculator that it is what it looks like. I would recommend on your sketch that you label the X values of your max and min, because that's going to help you with your intervals. So increase and decrease in intervals. So you kind of want to go left to right. So if you're, and when you remember, when you're doing these intervals, you're only looking at your X values, like where is it increase between what X values and what X values is it decrease in between? So what color do I want to use? Purple. So if you look from here to here, your graph is increasing. So that would be, remember, you're thinking of X values. So from negative infinity to this negative 2.2, your graph is increasing. But then you look, your graph decreases from here to your minimum. So from negative 2.2 to negative 0.6, it's decreasing. And then from negative 0.6, oh, wait, I wrote that wrong too. Gosh dang it. Sorry. And you guys are probably like, wait. Swope. Sorry, this should have been a negative 0.5. Because remember, like I said, we're looking at the X values, not the Y values. So let me fix this. So sorry, this should have been from negative 2.2 to negative 0.5. So apologies. But like I was saying, sorry, back to this, it increases from negative 0.5 onward. So that would be negative 0.5 to positive infinity. So if you were yelling at me, you are correct. Okay. Domain and range, you just kind of want to use your finished product. Your domain, it goes to the left and right forever. So that would be all real numbers, or you could also write from negative infinity to positive infinity if you want to use the intervals. And our range is actually the similar case. It goes down forever and it goes up forever. So this would also be all real numbers. One tip, if you have an odd degree function, you're going to have all real numbers for your domain and range. If it's an even degree, your domain will be all real numbers, but your range, you'll have to think about it a little bit more. But I'm pretty sure the one on your test is also cubic though. So honestly, the domain and range shouldn't really be too much of an issue on the test for this. So honestly, I think question 4 is kind of a rough one. It's got a lot to it. And there are a lot of points to pick up on here, even if you miss one of these things. Like each one of these things is going to be worth points. So definitely take your time with this one. And if there is something you're struggling with, answer anything you possibly can, because you'll at least pick up quite a few points, even if you mess up, say, like your intervals or something like that. But so just to kind of reiterate, to find your x-intercepts or zeros, you're going to want to factor what I give you, and it should factor. You shouldn't have to use anything crazy. It should work out pretty nice. But for your local max and min, though, make sure you use your calculator to find that, because there's no way to really do that by hand. I mean, other than kind of like guessing and checking, you can kind of approximate it that way. All right, so let me pause this. All right, so looking at question 5, they're going to give us a graph. They give us the function and the graph itself. They want to know how many imaginary solutions must there be? How do you know? So you want to look at your graph to see how many solutions you have, and you want to consider the multiplicity as well. So both of these, there's 2 zeros on your graph, and both of them cross through. So that means you have a multiplicity of 1 for both of these. So that means really there's 2 real solutions. So if you remember, your degree tells you how many answers you're going to have. So since it's a quartic function, you're going to have 4 solutions in total. So if there's 2 real solutions, that implies that there must be 2 imaginary solutions to get to that 4 total. So there would be 2. But keep in mind, just for example, say you had something that looked like this, say like it bounced and it crossed through. Remember, let's just say it was a 5th power. Let's say it was that. Well, this would be a multiplicity of 1. This would count as a multiplicity of 2. So there's really like kind of like between the real solutions, there's 3 real solutions. Because remember, a multiplicity of 2 counts as twice. So this would also, like if this was a problem, this would also have 2 imaginary solutions. One tip, imaginary solutions always come in pairs. That's like a theorem I kind of skipped over a little bit this year, but Like you'll never just have a single imaginary solution. You'll always have 2, 4, 6, or 8, something like that. Just a kind of a heads up there. But that's it for a question like this. But I'm gonna ask, like, this is a good question because I'm gonna ask some questions like these where it's not really necessarily a lot to do, but you do need to kind of think through it. And I do want you to explain it. Like, so I mean, and I don't need like a written paragraph by any means, but just at least demonstrate to me that there's, like, here, I probably should have said this when I wrote it. There's 4 total solutions. So based on our graph, we know there's 2 real solutions, so there has to be 2 imaginary solutions. You don't have to write it out super formal, but you need to at least write enough so I can see what logic you use to get it. So talk about how many solutions there are, how many real solutions, and then kind of use that to show me how you got your answer. Don't just put like there's this many imaginary solutions. I want to know how you knew that for a question like this. Question 6, you're going to be asked to find all the zeros. So we're going to be using kind of our earlier methods, factor in, difference of squares, difference of cubes, sum of cubes, all that good stuff, group in. You shouldn't have to use synthetic division for any of these. So this first question, you always want to look for a GCF. You can factor out an X. Then you want to see, well, can you factor what's left inside there? This one, you should be able to factor out quite nicely. That would be x plus 6, like what multiplies negative 12 and adds up the positive 4. That would be x plus 6, x minus 2. So if you solve, remember, you want your solutions, so that would be 0. That would be negative 6. Basically, if you set each one of these terms equal to 0 and solved, this would be positive 2. And that would be it for this question. The second box, we have a difference of squares. If you remember, you could factor that. Like, remember what squared would give you 4x squared? Well, that would be 2x squared, and this would be really 9 squared. So you have a difference of 2 squares. So remember, that's going to be 2x plus 9, 2x minus 9. You could also solve this one. You could literally just add the 81 over, divide by 4, then square root. So there's actually more than one way you could do this problem. If you solve this, you're going to get x equals negative 9 over 2. Or if you got a decimal, you would have got negative 4.5. And this one's going to be positive 9 over 2 or 4.5. I don't care if you leave it as a fraction or a decimal, whatever you prefer. But like I said, you also could have added the 81 over, divided by 4, square rooted both sides. Got plus, if you did it that way, don't forget your plus or minus in your answer though. But this is an example of a question where you actually kind of have 2 ways definitely to go about it. All right, question 3. This is a difference of cubes, or I mean, it's not a sum of cubes, but you're going to want to remember those formulas. So I'm going to go ahead and write those down really quick. I'm going to pause the video. All right, so as you can see now below, you should see the 2 formulas for sum or difference of cubes. Obviously, this is a difference, so we're interested in this formula. Remember well, first off, this one's actually a little bit tricky. The first thing is you could factor out a 2. So you might have been asking, how did you even think that was a difference of cubes, Mr. Swope? Sorry, I kind of just saw that in my brain. I forgot to write it down. But now you should see it's a difference of cubes, what we have inside after we pull out that GCF. So our A is 1x and our B is 3. Like that's what, if you cubed it, would give you what you started with. So we're going to use this formula I've highlighted in green. So we're going to have x minus 3. Then we're going to have x squared plus a times b. That would be 3x plus b squared would be 9. And I'm going to erase these formulas. Or maybe I'll cut them out. Just make it really small. I'll keep them here just in case anyone is trying to see these anywhere later. So, I mean, if we saw, oops, I deleted part of this. It's kind of weird. But if you solve this, I mean, you're just going to get x equals 3. But you always have to do quadratic formula for your trinomial part. You're always going to get imaginary solutions. So if you do your quadratic formula, it would be negative 3 plus or minus 2 times a. That would be 2. Square root of b squared, so that would be 9 or 3. I'll just write it. It would be 3 squared minus 4 times 1 times 9. So we got to simplify this. I'm going to rate a little bit too big. We'll make it work. So if you simplify that radical part, that would really be 9 minus 4 times 1 times 9 would be 36. So 9 minus 36, that would be what? 27? So the square root negative 27, right? Let me just make sure my math's not wrong. 9 minus 36. 21, 27, right? Okay. I think we're good. Hopefully. I'm sure someone will let me know if I'm wrong. So if you want to simplify this, this would be negative 1.5, negative 3 divided by 2. And then if you put in your calculator the square root of, don't put the negative, just put the square root of positive 27. Let me pull up my calculator. So the square root of 27 is roughly 5.19 divided by 2. It'd be roughly, I'm going to round it up, it'd be roughly 2.6i. Like these would be your two imaginary solutions. So that would be it for this one, but do make sure you solve. I know in the Delta Math section, they just had you get it into the factored form. I want you to actually solve it here on your test. All right, and then our last question, here, let me just kind of erase this. It's not covering up the question. Remember, if you have 4 terms, usually a good method to check, it might not always work, is grouping. So if you pull out an x squared out of that first group, you pull out a negative 1 out of that second group. Like remember, your goal when you're doing the grouping is these should always be the same, like what you have in your binomials. So you would have x squared minus 1, you put the GCFs together, then you copy down one of those binomials that were the same. If you solve these, I'm just going to change colors because it's all kind of running together. If you solve this first part, if you added the 1, square rooted it, you would get x equals plus or minus 1, right? And then if you solve this, you would just get x equals 1. So I guess if you wanted to write it, you could say x equals 1. It has a multiplicity of 2. And then x equals negative 1 if you want. But that x equals 1 repeats twice, basically, is what you're seeing there. All right, so that's the idea in this section. Like I said, you're going to use a lot of those different ways. This is coming from section 5.3 if you're looking for notes or more examples, but basically you're solving these any way you can. But let me know if you have any questions. So let's move on to question 7. Let me erase all this. It's starting to run over each other. 7, they just want you to solve, or not solve even, just divide using synthetic division. Excuse me. So the only thing, remember, when you have a factor, you got to figure out what would your 0 be there. So remember, you got to basically do the opposite if it's written like a factor. So that would be x equals 2. And then you're going to write your coefficients. Ooh, this one's actually a little bit tricky. Remember, if you're missing a term, this is really like there's really a 0x squared there that's not written. So when you do your synthetic division, you got to make sure when you write your coefficients, you put that placeholder for your x squared like a 0 in that place. If you don't do that, you're going to have a bad time. So if you do your synthetic division, though, and you'll see we actually don't get a remainder of 0, which I know it's been a bit because when we're solving all these ones, they usually divide evenly. So our answer, remember, your degrees all go down by 1, but our answer would be x squared plus 2x minus 4. And then usually you just add your remainder. So you put that negative 11 and you put it over what you divided by. So over that x minus 2. So that would be your answer. So you don't have to solve this or do anything like that. It just asks you to divide. But keep in mind, like I said, that's a good reminder. If you don't have one of your coefficients, like it's in that standard form, you're missing one of your degrees, make sure you put a 0 in its place. Because if you don't do that, you're going to have a bad time. You're going to make a mistake. All right. These next 2 questions are kind of like what we've been focusing on in section 5.5 and 5.6. We're going to use synthetic division to solve these. And we're going to find all the complex answers. So it's possible we'll have some imaginary solutions in these questions. So the first thing you want to do, sorry, I'm just grabbing my paper here, so I'll have to flip back and forth. But Remember, you want to go to your graphing calculator, press that y equals button. I'm clearing out what I already had. So the original equation, hopefully this is the same I have here, 4x to the third minus 8x squared minus 15x plus 9. Let me just double check. Is that the same question on here? Minus 8x squared minus 15x plus 9. Okay, good. Just wanted to double check. All right, so once you got it entered in, you're going to press that graph button. You can kind of see a picture. So it looks like it crosses at 3 places, which since we have a cubic function, that indicates to me that, well, then there must just be 3 real solutions. There are not any imaginary solutions. So we want to go to our table. We want to find at least one of our points where we have a y value of 0. Might have to scroll a bit, but finally I see one at 3. So that's going to be our starting point. So one of our solutions is x equals 3. We're going to use synthetic division to hopefully find the other 2 solutions. So the first term comes down, multiply that by 3, that would be 12. Bring that down, multiply by 3, that would be negative 12. All right, I paused it because I thought I did something wrong, and of course I did. Sorry. So you bring down to 4, multiply by 3, that's 12. That would be positive 4 coming down. So this should be a positive 12. So something's off here. And then you should get a negative 9. Because remember, with these problems, when you do your synthetic division, you should never get a remainder if it's actually a solution. So that's kind of, I saw it wasn't going to work out. And I was like, uh-oh, better pause and see what I did. Remember, all your degrees go down by 1. That would be a square. That would be an x. That would be a constant. So now we want to factor this. And when you get a quadratic, you can always solve this. Sometimes it might be easier than others, but you can always use quadratic formula. This one, I think you can do group in or quadratic formula. It's kind of your choice. I'm just going to do quadratic formula. Why not? But I'm pretty dang sure you can do group in. But we'll do quadratic formula so we don't have to think as much. That'd be the square root of 4 squared minus 4 times our a is 4 times our c is negative 3. So if we clean this up a bit, what would that be? That would be 16 minus 16 times negative 3. That would turn to a plus. That would be plus 48. So 16 plus 48, 64. Let me plug that in. I feel like I'm going to make an oopsie. So we'd have 16 times 3, 3, 2, 48. Okay, it is 64. All right. Gotta trust yourself, I guess, a little bit more sometimes. Okay, so that's going to be 8 when you square root that. Then if you want to clean this up or actually get your actual solutions, I mean, this would be like negative 1/2 plus or minus 1. And you could actually like work it out like negative 1/2 plus 1 would be positive 1/2. And then if you did negative 1/2 minus 1, you would get negative like 3/2 or negative 1.5. And that's why these answers didn't show up on my table. Like if you notice, like I didn't see those ones because they're decimals. Those are not going to show up. All right, and Zoom was yelling at me, so I hope this recorded fine for that question. We'll have to see. All right, but question 9, similar idea. We're going to graph this function. Let's see, where's it at? All right, and so we're going to go to our graphing calculator. We're going to clear what we had. Okay, so just typing this in, just being careful. All right, once you got it in, you're going to press graph. Looks like I have 3 real solutions, but keep in mind this bounces, so that really counts as 2 solutions. So looks like we're not going to get any imaginary solutions in this question. At least that would be my guess. The first solution I see in my table is -2. So So we'll start with that at least. Do our synthetic division. Okay, so we really have, it goes down by 1 degree. So x cubed, that would be really 0x squared. So minus 5x, then minus 2. Unfortunately, this is not something I can really factor. Not seeing anything I can really do with this. I can't do grouping. I can't pull out a GCF. It's a cubic. It's not even a quadratic, so I can't do quadratic formula. Oh boy. So let me check my table. I'm hoping there's another solution, so maybe I can do synthetic division again. Oh, okay. Well, all right. So you might be looking at your table. Uh-oh. There's no other zeros. But remember from our graph, and this one's really tricky. If you look at -2, you have a multiplicity of 2 because it bounces there. So that means that solution really happens twice. So we can use it twice in our synthetic division. So this one's kind of tricky. I'll be honest. I don't know if I would put this on your test necessarily. And one thing when we do our synthetic division, don't forget we have to use this 0 as a placeholder. So if we do our synthetic division now, though, that would be +4, +2, you get 0. So this would be x squared minus 2x minus 1. Unfortunately, there's nothing that multiplies the -1 and adds up to -2. So we do need to do quadratic formula. That means we must be getting, wait, let me just make sure. Am I goofing? Let me pause. Okay. No, we're good. We're good. We do need to do quadratic formula, but I was just saying, like, from our graph, though, we shouldn't get any imaginary solutions. But just because you have to do quadratic formula doesn't mean you're going to get imaginary solutions necessarily. So if we do the -b, that would be +2 over 2 square root. It would be really -2 squared. So I'm going to kind of simplify it earlier, but that would be a 4 for your b squared part. -4 times 1 times -1. With your signs, that would really be 4 plus 4. So you're really going to have this 2 plus or minus the square root of 8 over 2. And honestly, you could keep your answer if you like. But if you want to clean it up, especially because you're not getting imaginary solutions, if you clean that up, like if you get your answers, you should that you get x equals about 2.4-ish, that you get x equals roughly -0.4, depending on how you round. So we would have these two solutions, and then don't forget, you would have x equals -2, and that really had a multiplicity of 2. And I forgot I even put this hint here. I didn't read it obviously before I went through our question, but yeah, I did put that in the notes up there. Okay, so you'll have a couple of these types of questions, and then our final section is this binomial theorem stuff. So just remember when you label your rows, it starts with 0. Wait, way too big. I'm gonna write like a clown. Okay, 4 is as high as it goes. Okay, so you look at your degree. So this one's a 4. So you go to really the 5th row because you start with 0 when you count. So those are going to be our coefficients. So I usually like to just write those and put, like I said, my empty parentheses. And from your binomial, you like your first part goes in your first parentheses, the second part goes in the second parentheses. So for all these, it's going to be an x and a 2. Okay, so with your first set of parentheses, your power starts as the same and it goes down by 1 each like term. For your other set of parentheses, it starts at 0 and it goes up by 1 each term. So then we just need to clean this up to get our final answer. So I'd like to kind of just focus on the coefficients of the numbers. Like this would just be a 1 and a 1 because anything up to the 0 power turns to 1. So this would just be an x to the 4th. This one, you have a 4 and you have a 2. So that would just be 8 x to the third. All right, then in our next part, we have a 6, we have a 2 squared, that's a 4. So 6 times 4 would be 24, and then our x part would be squared. For our next part, we got a 4. 2 to the third power is 8, so 4 times 8 is 32. The variable part would just be an x. This one, you have a 1. 2 to the fourth power, that's 2 times 2 is 4, times 2 would be 8, times 2 would be 16. And your x to the 0 part basically goes away. So that would be your final answer. And then our last one, since it's a cubic or it's up to the third power, you're looking at this row. So yeah, I'm going to write my coefficients in my parentheses. Okay, remember your first term, like the first part of your binomial goes in the first parentheses, and then since it's a -1, you're going to treat it like a -1. Okay, so same idea with your powers. First parentheses starts at 3, goes down 1 each time, and your second parentheses starts at 0 and goes up by 1 each time. So we just really need to clean this up. Just be careful because in this problem we got a coefficient in this box, so we do need to cube that too. So this would be a 1, 2 to the third power is an 8. I mean, -1 up to 0 is just 1, so this would be 8x cubed. For this one, we have a 3. 2 squared would be a 4. -1 up to the first power would stay a negative. So this would be -12 once you multiply that all out. So we got a 3. 2 to the first is a 2. -1 squared would be a +1. If you multiply that out, you're going to get +6x. And this last spot, I mean, 2 up to 0 is just 1. -1 to the third power would be -1. So all together would be -1. And your x to 0, you don't have a variable part left. So that is your review. I'm sorry, I had to keep pausing. I had things coming up around here. So I hope it's not too disjointed, but I hope this is helpful. I definitely would reference this video during your test. Skip around to any questions you're going to be having trouble with. But please let me know if you have any questions about this review or anything else we've been doing in here.